We'll start by looking at the effect of temperature on changing states of matter. When you heat or cool matter, its state can change. Let's take a block of ice as an example. If you heat it, the kinetic energy of the particles inside the ice increases, making them move faster. As they vibrate more intensely, the forces holding them together weaken, and eventually the ice starts to melt. This is called fusion, which is just a fancy word for melting, really. The temperature at which a solid melts is called its melting point. For ice, this is 273 Kelvin or 0 degrees Celsius. But here's the interesting part. When ice reaches its melting point, its temperature stays constant until all the ice melts. Why? Well, the heat energy is being used to break the bonds between the particles, or in other words, overcome the force of attraction between the particles in the solid. This hidden energy is called the latent heat of fusion. So, what is latent heat? It is the heat energy required to change the state of matter without changing its temperature. The latent heat of fusion is the energy needed to turn 1 kg of a solid into a liquid at its melting point. Once the ice turns into water, we can continue heating it. At a certain point, the water starts boiling. That's when it changes from a liquid to a gas. This temperature is called the boiling point, which for water is 373 Kelvin or 100 degrees Celsius. The water doesn't just disappear, its particles gain enough energy to escape into the air as water vapor. The energy needed to turn water into vapor is called the latent heat of vaporization. The same amount of energy is needed to break the attraction between water particles and turn them into gas. Now, not all substances change state the same way. Some solids skip the liquid phase altogether and go straight from solid to gas. This process is called sublimation. A great example is camphor, whose force of attraction between its particles is weaker than other solids. At room temperature, these forces are able to hold it in a solid state, but with heat, they're easily overcome, allowing it to turn directly into gas. And while heating gives us fusion, vaporization, and sublimation, cooling gives us solidification, condensation, and deposition.